Welcome to a lesson on the multiplication and division of integers. Let's go ahead and get started. Let's first start by talking about some preliminary ideas. First, the multiplication of natural numbers can be viewed as repeated addition. So for example, we can view 3 times 5 to mean 3 groups of 5, or 5 plus 5 plus 5, which would equal 15. And the same idea, 6 times 4 means 6 groups of 4, which would give us 24. The second idea is the commutative property. When two numbers are multiplied together, the product is the same regardless of the order. So for example, 4 times 2 is equal to 2 times 4, which is equal to 8. Okay, let's start by talking about the product of a negative number and a positive number. Most textbooks state the rule as to multiply a positive number and a negative number, you multiply their absolute values and the answer is negative. So 4 times negative 3 would give us negative 12. But to justify this, we could think of 4 times negative 3 as we want 4 groups of negative 3, or we want to add negative 3 to itself 4 times, which of course would give us negative 12. Again, we want 4 groups of negative 3, and then we sum them. On the second problem, negative 2 times positive 5 is going to equal negative 10. But again, we could rewrite this as 5 times negative 2, which of course is still negative 10. But now we can apply the same idea. We want 5 groups of negative 2. So we want to sum 5 groups of negative 2, which would give us the negative 10. Now the idea of multiplication as repeated addition breaks down a little bit when we start talking about multiplying positive and negative fractions. Now this video does focus mainly on integers, but at this point when we introduce fractions, we do just want to think a positive times a negative will be negative, and then we just multiply across the top. That would be 2 times 4, which would give us 8. 3 times 5 would be 15. Really what we're doing here is we want 2/3 of negative 4/5. So we could think of breaking this into 3 parts and then taking 2 of them, but that gets a little more complicated when we deal with fractions. So again, by this point we would just follow the rule. Next, the product of 2 negative numbers. To multiply 2 negative numbers, we multiply their absolute values, and the answer is positive. Again, this rule is correct, but it doesn't really justify why a negative times a negative is a positive. So let's take a look at these two examples first. Negative 4 times negative 3 would be a positive 12 based upon this rule, and negative 2 times negative 5 would be positive 10. But let's take a moment and justify why this would be true. Remember that when we write down the number negative 4, we could think of this as the opposite of positive 4. So when I multiply this by negative 3, I could view this as the opposite of positive 4 times negative 3. Well, based upon our previous argument, positive 4 times negative 3 is negative 12, and the opposite of negative 12 would be positive 12. And the same thing for the second example. We could think of this as the opposite of 2 times negative 5. That would be the opposite of negative 10, or positive 10. If that's still not convincing enough, we could go back to the idea of multiplication being repeated addition. If I take a look at negative 4 times negative 3, going back to that idea of multiplication being repeated addition, well here if I want a negative number of negative 3's, this would translate into repeated subtraction. So if I want negative 4 of negative 3, I'd have to subtract negative 3 4 times. Well, we know from adding and subtracting integers, subtracting a negative is the same as adding a positive. So this translates into 3 plus 3 plus 3 plus 3, which is equal to positive 12. So you could think of multiplying a negative times a negative as repeated subtraction. but I think the idea of taking the opposite of a positive times a negative is a little clearer. Next, when 3 or more numbers are multiplied, we can just multiply 2 at a time and follow the rules that we've already discussed, or the product of an even number of negative numbers is positive, and the product of an odd number of negative numbers is negative. So for example, on part A here we have 3 negative numbers being multiplied together. 3 is odd, therefore this product must be negative. And then we can just multiply the absolute value of these together. 2 times 3, which would be 6, times 5 would give us 30, but we already know our answer is going to be negative. On part B, we have 4 negative numbers being multiplied together. So we have an even number of negative numbers, therefore our product will be positive. So now we can just multiply the absolute value of these. So 1 times 5 is 5, times 2 is 10, times 3 is 30. Again, our product is positive. Okay, I have a couple other ideas I want to discuss. The next one is the multiplication property of 0. For any real number a, 0 times a is equal to a times 0, which is equal to 0, which means the product of 0 in any number is going to be 0. So 5 times 0 is 0, 0 times 5 is equal to 0. Now let's talk about the general rules for not only multiplication but also division. The rules for multiplication and division of signed numbers are the same. If you're multiplying or dividing two numbers where the signs are the same, both positive or both negative, the answer is positive. And if the two numbers have different signs, meaning one's positive and one's negative, the answer will be negative. So to summarize here, if we have a positive times a positive, we get a positive, but also a negative times a negative is positive. So if the signs are the same, the answer will be positive, and if the signs are different, the answer will be negative, and the same is true for division. So if we use those rules here, a positive divided by a negative will be negative, and 14 divided by 2 is 7, so we have negative 7. A negative divided by a negative will be positive, and 24 divided by 6 equals 4. On number 3, we'll just take it 2 at a time. Since division and multiplication have the same priority, we're performing order of operations. A negative divided by a negative will be positive, so here we have positive 4 times negative 2, and now a positive times a negative is negative, so we have negative 8. Okay, let's take a look at division involving 0. For any real number k, k divided by 0 is undefined. So the two examples, first we have 12 divided by 0, the second example we have 0 divided by 5. The way I remember this is I take a look at this and I think some number k over 0. So if you think k over o or ko, if you know anything about boxing or mixed martial arts, I think undefined when I see the word ko. And on the second example, 0 over 5, I think 0 over k or ok. And ok means we can perform this division. It is defined and it equals 0. And we'll end by thinking about a poem that we can use to remember the rules for multiplying and dividing integers. And here's how it works. The word hate represents a negative number, and the word love represents a positive number. So if you love to love, or you have a positive and a positive, then you love. So the product or quotient will be positive. If you love to hate, then you hate. So that means a positive and a negative results in a negative when you're multiplying or dividing. And next, if you hate to love, or you have a negative and a positive, then the result will be negative when you multiply or divide. And lastly, if you hate to hate, you have a negative and a negative, then you love. So if you multiply or divide a negative times a negative, you get a positive. So one more time, if you love to love, then you love. If you love to hate, then you hate. And if you hate to love, then you hate. And if you hate to hate, then you love. Thank you and have a good day.